great to see you here. My name is Luc de Ceuster, founder of the Ceuster Academy, and in this video I'm going to talk about some statistics, numbers and their significance. We will be doing some calculations, and it's very important to understand what we do with these numbers. Now, before continuing, don't forget to click on the subscribe button, click on the bell button, and every time when there is a new video, YouTube will inform you about it. Let's have a look at the first part of this video, which is about statistics and probability. Statistics is important when we want to deal with variability and when we want to take measures about variable events, uncertainty, and when we want to do some calculations. Now, when we look at observations, when we see what's happening around us, when we are measuring parameters, you will see that basically you will find out that whenever you do the same things, you will have different values. And that's one of the elements why statistics and probability are important, because taking into account all these elements, we can find probability distributions to describe these variations. One of the elements that are used a lot is the normal distribution, but in project management we also look at a beta distribution. We will look at this later and I will explain you what it is about, but also the triangular distribution, and in some cases we even may have all kinds of different probability distributions. When you want to know more about those, you can look at your course of statistics and you will understand how we can use those different distributions. Now, when we look at probabilities, it helps us to explain what uncertainty is, and we have information of the possible occurrence of specific events. So there is a certain probability that some event will happen, and we can find that probability based on observations and experiences. When we use this in combination with probability distributions, we can in fact identify what effects we can or events we can expect and what the probability of that event would be. For example, when we have a normal distribution and we have an average of, let's say, duration of 150 days, a standard deviation of 30 days, we can say that we have about 84% probability that our project will be finished in 180 days or less, the average plus one standard deviation. So these are the things that will help us to deal with uncertainty in projects. We can, in fact, build a relationship where we have on one side, on the x-axis, the duration of a project. We can have different durations, and on the y-axis we can have in fact the probability that the project will be finished in less than that duration, or we can have on the x-axis, for example, the cost of the project. So we can say that there is a certain probability that the project will be costing less than a certain amount. Now, when we do calculations, we also have to look at some numbers and some decimals, and you may have seen these things in high school and university in your math courses, but I just want to come back for a few minutes back to the numbers and the decimals, because when you were looking at the numbers, we started with natural numbers and integers. Natural numbers come from counting, and we typically started with 1. Look at the Roman numbers, they didn't have 0. Later 0 was added, and we also added the negative numbers and created what we call the integers. So basically with the natural numbers and with the integers, we can express positive, and with the integers also negative values. Those two categories have no decimals, so it's 1 car, 2 cars, 3 cars, minus $5, plus $5, no decimals. These are in fact numbers that are just having the number itself, no decimals. Of course, this is not sufficient. We also defined what we call the rational numbers, and we created numbers like 1/2, 1/4, 1/8, and so on. And we see that in some cases the measures are, for example, used 1/8 of an inch, things like that. So it's very interesting to use the rational numbers. The rational numbers contain decimals, but there is a special way how we can recognize them because they have repeating decimals. Like 1/3 can be written as 0.3333, and 3 is the repeating decimals. Now there are also other numbers without repeating decimals, and we call them the irrational numbers. So the irrational numbers is in fact the set of all the numbers that have, let's say, cannot be expressed as a proportion of two integers. But it also contains the natural numbers, the integers, and the rational numbers. Now, rational numbers have an infinite number of decimals. But how many decimals do we need? When you do a calculation today, your calculator is giving you a very large number of decimals. Putting too many decimals has no sense. Before, people were calculating with a kind of ruler system where you almost did not have any decimals, but today Excel gives you 20 decimals. But how many are important for the calculations? Now we can have a look at this, because when we're going to work with those numbers, it may be interesting to know when we do reporting how many numbers do we have to use. And we call that the significance or the significant numbers, the significance of numbers. And when we look at those continuous rational numbers, how many decimals have a meaning? And I remember when I'm teaching math and my students tell me, our teacher in high school told me we have to have 2 decimals. That's a rule because then the teacher knows how to deal with everything. But in real life, nobody will tell you how many decimals you have to use. You have to find out how many decimals have a significance. And a significance means also about what can we do with those numbers. It means that we can in fact use them. So I tried to give you some examples and some explanations how we can deal with the significance of numbers and what principles you can apply when you are reporting to the numbers. So what is possible? What is practical? I have some examples from my training before, and typically in aviation school we had some pilots doing some calculations flying from A to B with some crosswind, and they had to calculate the heading to fly from A to B, and they calculated for example 52 degrees 35 minutes 34.7 seconds. Also we can say, well, we try to fill our car, we need so much petrol to go from A to B, so we calculated, for example, 37.256798 liter that we need. Now let's have a look at these elements a little bit deeper and find out what is the basic principle related to the significance of numbers. And I'm going to measure something, and based on that measurement I will say how many significant numbers do we have. But first of all, how do we calculate the number of significant numbers? Basically we start with the first number that is different from 0, and we count all the intermediate numbers until we reach the last number, and the last number has been obtained by estimation. So all the numbers except the last one we are 100% sure about. The last number is obtained by reasoning, by rounding. And let's have a look at this ruler and the piece of wood I tried to measure. So we just have the centimeters here. We can see that we have 8.5 and 6, and we see it's between 6 and 7. And when we look closer at it, when we take a deeper look, when we say, well, it's a little bit closer than to the 7 than to the 6. And what we can say here, that is the first number that is different from 0 is 8. The last number, the 7, is obtained by estimation. It's not 100% correct because we, in fact, between 6 and 7, a little bit closer than 7. This means that that last number 7 has been obtained by reasoning, by estimation. It's not correct. 8 has a 100% validity, while 7 is an estimation. And in this case, we have two significant numbers. Let's have a look at our airplane example. So typically what we have an airplane flying from A to B, and we have some wind coming from the top, so that's why it puts the nose into the wind. And basically what we see here is that the airplane has a heading which is not equal to the heading or the magnetical, let's say, indication of the line between A and B. So we have to fly at a specific heading. Now, the students calculated that heading considering the wind velocity and using trigonometry, a basic simple calculation. Now, when you try to fly 52 degrees and so many minutes and seconds, look at the magnetic indicator here. What do we see? Well, basically we see that we have a precision of 5 degrees. So if the instructor said, okay, fly the heading that you calculated, it was basically not possible, and the student failed. The student had to find a way to use the instruments and to do the calculations taking into account the precision of the instruments that are at the pilot's disposition. Filling up the tank of our car, it's basically the same thing. We can calculate the amount. Typically, we put there a quantity, we fill the tank, or we put a certain amount of money into the tank. We look at the money. But when we look at the possibilities, here we see we have two decimals, price or liters. So 18.76, when we have a calculation, we will have our calculation limited to basically two decimals. And here we see, in this case, with the examples we have four significant numbers starting from 8 and finishing with 6, because 6 is basically between 5.6 and 6.4. So basically we have those elements. This is already an estimation. We cannot have or find a more precise solution. It is not possible. So if we do a calculation and we want to know how many liters we want to put in our car, our calculation has to be limited to two decimals. And that's basically what's important when we're looking at the different applications. We have to adjust what we calculate, all those precisions, all those values that we calculate. We have to see that they have a meaning. So that was it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next video. Bye bye.